Okay, so we've done up to number 3. Number 4 is also another complex conjugate type of problem. So make sure you rationalize the function by finding the complex conjugate and multiplying the numerator and denominator by the complex conjugate. Okay, and remember that for the complex conjugate on number 4, I'm going to help you with that just a little. Okay, so your complex conjugate for number 4 is in the denominator, which is square root of 5h plus 4. The only thing that changes is plus minus 2. You're going to multiply top and bottom by it and see what happens, okay? Number 5, again, plug and chug. If plugging doesn't work, then factor, okay? Okay, so plug in and see what happens. If you get a 0 in the denominator, then factor, okay? Same thing with number 6, plug in and then factor. Again, plug in and then factor. Number 7 is a complex conjugate type of problem. You gotta find the complex conjugate and then multiply top and bottom by it, okay? Alright, so let's see what's going on with number 8. Number 8, my question to you, I'm not gonna help you, but my question to you is, you know what, let me just look at the problem. Okay, my question to you on number 8A is, what kind of rule would you be doing? If it's division, do you do product or do you do quotient? So think about it. What rule do you do to take the derivative? Again, over here, is this supposed to be a product rule? Think about it. Or is it supposed to be a chain rule? Okay. One quick thing I do want to tell you, before you take the derivative, you need to do this. Change the square root as 1/2. Okay, now think about it. Are you going to do chain rule and then find the tangent of 1 plus x squared? Okay, make sure you do the chain rule, meaning take care of the power. 1/2 comes in front of, and then when you do chain rule, you multiply. Once you take derivative of outside, and outside would be the power, you have to take derivative of inside, which is tangent of 1x squared, 1 plus x squared, and you have to keep on multiplying. That's what the chain rule is. So once you've multiplied by derivative of tangent, then you have to multiply it again on one line. You're multiplying. That's what the then you have to multiply by the derivative of 1 plus x squared. Okay, so first in one line you're gonna do it all. Bring the 1/2 in front. And then write tangent 1 plus x squared. Make sure you subtract 1 from it. Make sure you apply the power rule. Times, now you do the derivative of tangent 1 plus x squared. Multiply that by derivative of tangent 1 plus x squared. Think of 1 plus x squared as x. So tangent of x, think about it. Derivative of tangent is what? And then again on the same line, times derivative of inside. So this is a long chain rule. This one, it's going to be a chain rule because you got to do the derivative of outside, which is 2. Make sure you subtract 1, and then times it by, well, 2 cosine 2y times derivative of cosine 2y times derivative of 2y. Okay, you can rewind me to hear that again. Times the regular secant 2y cubed, because this is a product rule. Two things are multiplying. Plus, now you're going to take the derivative of secant 2y cubed. Again, chain rule, bring the 3 in front of secant 2y, so it will be 3 secant 2y times derivative of secant 2y times the derivative of 2y. Okay, over here, this is, think about it, is it a product or is it quotient? Is this a product or is this a quotient? Well, it's product, not a quotient. Do not forget to write 1 over z as, I'm going to help you with that. Okay, always 1 over anything, write it as a negative power, okay? And take care of the power first, and then you can apply your product rule, okay? What else? Let's see. This one, again, product or quotient. Okay, this question is asking you to find the derivative using the definition. So for number 9, all you're going to do is plug in x plus h everywhere you see x, and plug in x minus h everywhere. So basically, I'm going to set this up for you. So f of x is equal to x plus x squared. That means f of x plus h, everywhere you see x, you put an x plus h. Everywhere you see an x, you put an x plus h. And whenever you plug in something, this is my way and it is my way or the highway, you have to put parentheses. X plus h, whenever you plug in, parentheses is a must. Square. Okay, so x plus h square, that's what you plug in for. See, f of x plus h is equal to x plus h square, so I'm just plugging in this guy with x plus h square minus f of x minus h. Well, everywhere you see x, you put x minus h and square it. So f of x minus h is going to be x minus h square. Okay, now it is a you're the one who's gonna have to simplify this. Make sure you know how to expand it. Either FOIL x plus h times x plus h, x minus h times x minus h, or use the formula I showed you, x squared plus a squared plus 2ab plus b squared. That special formula, how you multiply the inside and double it, and then you square the first and square the last. Or do the FOIL, take the long way. Differentiate. Again, this means take derivatives. Derivatives will never ever leave you alone. I didn't talk about this in class, derivative of e function. Actually, I did briefly, but the way you would take derivative of an e function, this is product rule, by the way, because two things are multiplying, but the derivative of e function is always the same thing. So derivative of e to the negative 4x is e to the negative 4x. But wait a minute, this is a chain rule. You got to take derivative of 4x, which is, well, negative 4x, which is negative 4. Okay, and then you multiply it by sine 3x. Plus, I want you to take derivative of sine 3x, again using chain rule, multiplied by the regular e to the negative 4x. Okay, so that's how you do this. Let's say in this one, you would have to do quotient rule, and this one you gotta rewrite this. Any square root, please rewrite them. So again, you would have to do the chain rule. Bring the power in front, subtract 1 from it. Write this out as it is, times derivative of inside. Okay, all right.